as an application on Pascal's principle, let's have this example. This is a hydraulic jack example. This is just a kind of like a schematic diagram of how a hydraulic jack should look like. Okay, there is an operator who pushes on a circular piston in here. So the operator pushes on this end with a force that is equal to 25 Newton. So the force here is equal to 25 Newton. Okay, and the diameter of this piston here is 0.012 meters. Okay, all right. If the other end of the piston is this much, 0.7 meters in diameter, is much bigger than this end, how much force? So the force that is coming out from this end here, F2, what is it equal to? Okay, let's see if we can solve this problem. All right, how do we do that? Okay, we use Pascal's principle. We know that the pressure that is transferred throughout this hydraulic liquid is the same, and the pressure here should be equal to the pressure here. So the pressure on the left, I'm going to call it P1, must equal to the pressure on the right, I'm going to call it P2. The pressure is equal to F1 over A1 for P1, and the pressure is equal to F2 over A2 for P2. Now F1 is given 25 Newton. A1 is not given because we're given only the diameter of this piston. Okay, we know that in general, I'm going to put it here, the surface area of a circle that has a radius r is equal to pi r squared. Please remember this. This is very important to memorize it. Okay, so F1 will be here 25 divided by pi. Now r is the radius, but we are given the diameter, so we have to divide this by 2. So this is divided by 2. 0.012 divided by 2 is equal to 0.006. Okay, and it's square, as you can see, so I have to square this. We should not forget that. Okay, now this would be equal to the other side, F2 divided by, again, pi r2 square, and r2 is equal to 0.75 divided by 2, and this number should be all squared. Okay, or we can calculate what 0.75 divided by 2, then we square it. It's the same. Now remember, pi with pi goes away. The only unknown in this equation is F2. After some solution, we find out that F2 is equal to 97,656 Newton. That's amazing, isn't it? Can you believe that? So we put only a 25 Newton force on one end. This could be a small force of your hand, and then the other side you get 97,000 Newton. The weight of your car is about between 15 to 20,000 Newton. So this is probably a big truck. So this is a very efficient hydraulic jack, if you will. Thank you.